Hello students. After the previous class, we can start with the topic intersection of sets, which we already started in the previous class. I told you that I will show you the Venn diagram for intersection of sets. So the topic is intersection of two sets. First of all, I will draw the universal set U. And in that, I will draw the set A with a circle and set B as a circle. So for intersection, I have to select the common region. This is the region which is present in both circle A and circle B. So the shaded region indicates A intersection B. Suppose if in the universal set, this is the universal set again, if the circle A and circle B are far apart from each other, then they will have nothing common in between them. That means A intersection B is nothing. It is an empty set. Then in such case, A and B are called as disjoint sets. For example, if I take the set A as 2, 4, 6, 8 and the set B having 1, 3, 5, 7. If you want to take A intersection B, nothing is common in between these two sets. So it will be empty set or phi. In such cases, A and B are called disjoint sets. Now there are some operations on intersection also, like we had for union. The first one is commutative law. The first law is commutative law, and that is A intersection B is equal to B intersections A. The second one is associative law. Associative law is A intersection B intersection C is same as A intersection B intersection C. Then the third one is law of phi and U, empty set and universal set. That is, phi intersection A will be phi only and U intersection A will be A only. Then the fourth one is A intersection A is A only. This is called idempotent law. The next one is distributive law. In distributive law, you can have A intersection B union C as A intersection B union A intersection C. Here, intersection distributes over union. Now, we will learn many things using Venn diagram. The first one is, suppose if you take this as universal set, in which we have the set A, the set B, and the set C. Suppose I am shading B circle completely, then I am shading C circle also. That means this is B union C. Similarly, I will take universal set. In this, I will take A circle. Let this be B circle and let this be C circle. I am shading the region common to circle A and circle B. So this diagram denotes A intersection B. Okay, next one. Let us take universal set again. In this, again I will draw circle A, set B, and set C. Now I am shading the region common between A and C and the region common between A and B. That means I am shading A intersection B with A intersection C. So A intersection is distributed over B union C, over union. So on the whole, I can say this diagram represents A intersection B union C. Let us take another diagram. This is universal set. In this, I have set A, set B, and set C. Here I am shading the region common between A and C. So this diagram represents A intersection C. Let us take another diagram. This is universal set. In this, I will draw set A, set B, and set C. Now here I am drawing the common region between A and B and the common region between A and C. So that means I am drawing A intersection B along with A intersection C. Almost these two are same. Next topic, we can go to difference of sets. What is difference of sets? Symbolically, I will write A minus B. But the meaning is it has the elements X such that X belongs to only A and X does not belong to set B. That is the meaning. If you want example, let the set A has 1, 2, 3, 4, 5, 6 numbers and the set B has 2, 4, 6, 8. I have to find out A minus B and B minus A. So from A, whatever you have in B, that you remove. Remove 2, 4 and 6. Of course, you can't remove 8. So A minus B means from A you have removed B. So left is 1, 3, 5. B minus A means from B, whatever is there in A, that you have to remove. That means you can't remove 1, remove 2. You can't remove 3, remove 4. You can't remove 5, remove 6. So left in B is only 8. And you can see here A minus B is not same as B minus A. Let us take one more example. V is the set having A, E, I, O, U. B is the set having A, I, K, U. You have to find V minus B and B minus V. From V, remove the elements of B. That is remove A, remove I, K you can't remove U. Left is E comma U. Now B minus V. From B, Remove the elements of V. Remove A. E you can't remove. Remove I. O you can't remove. K you can't remove. O you can't remove. What about U? U you can remove. A, I, U. These you can remove. So left is K. This is how we can write here also. V minus B is not same as B minus V. Now, if you want to represent using Venn diagram, this A minus B, take universal set, take the set A, take the set B. A minus B means from the circle A, remove the circle B. Don't shade the circle B at all. This is A minus B. Suppose if you observe this Venn diagram, what will you write? This is the universal set. This is the set A and this is the set B. Suppose I will take this region. Just now I told you from set A, you're removing set B. So this is A minus B. But suppose if I shade this region, common region for A and B, this is called A intersection B. And now, if you combine both A minus B as well as A intersection B, total if you take, you will get the circle A, the set A. Now, if I shade this region, I'm shading only B region. I'm removing the A circle. So this represents from B, we are removing A. So if you take A intersection B as well as B minus A, you will get the set B total. Like this, you can study the Venn diagrams. It will be really very, very interesting. So with this, we have completed the conceptual part. We can go to now exercise 1.4. In exercise 1.4, we have many problems. We will try to do them one by one. Let me see the first question of exercise 1.4. We have here many questions. One by one, we will do them all, not to worry. Okay, the first question is find the union here. In that, the first one, X is having 1, 3, 5. Y is having 1, 2, 3. You have to find X union Y. So first write the elements of X, 1, 3, 5. Then write Y. You need not write 1 double times. So 2, you need not write 3. This is how you will write. Next one is A is the set having A, E, I, O, U. And B is having A, B, C. Now when you write A union B, first write the elements which are present in A. After that in B. A I need not write again, so I'll write B and I will write C. The third one. A is having X such that X is a natural number and multiple of 3. That means I have 3 1s, 3 2s, 3 threes, 3 fours, 3 fives, and so on. Now, B is a set having x such that x is a natural number less than 6. That means in this you will have 1, 2, 3, 4, 5 less than 6. Now you have to take A union B. So when I write A union B, I will write the numbers of the set B. That is 1, 2, 3, 4, 5. After that, I will write the set A. 3 already written. So 6, 9, 12, 15, and so on. Let's go to the fourth one. A is the set having x such that x is a natural number and x is greater than 1, less than or equal to 6. That means you will have 2, 3, 4, 5, 6. Next, B is a set having x such that x is a natural number and and I have written somewhere. Okay, and x is greater than 6, less than 10. So that means I will write 7, 8, 9. Now when I take A union B, first I will write the numbers present in the set A, then the numbers present in the set B. Next, fifth is A is the set having 1, 2, 3 and B is just an empty set. So when I write A union B, first I will write the elements of A. Then in B, I have nothing to write because it is an empty set. So just the elements of A. So aren't the questions easy? Very, very easy. Next, we will go to question number 2. Question number 2 says, A is having AB. B is having ABC. Is A subset of B? That's the first question. Elements of A comma B are present in A and A comma B are present in B also. So I can say A is subset of B. Now, what is A union B? I have to write the elements of A, then elements of B. A, B I need not write. I will just write C. This is nothing but A union B. What I got is nothing but the set B only. Let's go to question 3. If A and B are two sets such that A is subset of B, then what is A union B? Just now we have seen A is the subset of B. Then what is A union B? Same as B. So you have to write A union B is same as B. Question number 4. A is having 1, 2, 3, 4. B is having 3, 4, 5, 6. C is having 5, 6, 7, 8. And D is having 7, 8, 9, 10. Now first you have to find A union B. Write the elements of A, then elements of B. 3, 4 we need not write. We will write just 5, 6. Second one, A union C. Write the elements of A first, then elements of C. That is 5, 6, 7, 8. Third one, B union C. Write the elements of B first, then C. 5, 6 you need not write, just write 7, 8. Fourth, B union D. Write the elements of B first, then D. 7, 8, 9, 10. Next, fifth, A union B union C. Write the elements of A first, then B. Don't write 3, 4, write 5, 6. Then C. Don't write 5, 6, write 7, 8. Next, sixth is A union B union D. Write the elements of A first, 1, 2, 3, 4. Elements of B, 3, 4 you need not write, 5, 6. Elements of D, 7, 8, 9, 10. Next, seventh one, B union C union D. Write the elements of B, 3, 4, 5, 6. Elements of C, don't write 5, 6, just 7, 8. Elements of D, don't write 7, 8, just write 9, 10. So in this way, we have completed question number 4. Coming to question number 5, you have to find here intersection. This time, not union, intersection. The first one, X is having 1, 3, 5. Y is having 1, 2, 3. So X intersection Y is common in both. 1 and 3 are present in both. Next, A set is having A, E, I, O, U. The set B is having A, B, C. A intersection B is common. A is common, only A. So I'll write only A. Third one, A is the set having X such that X is a natural number and multiple of 3. So I will write 3 ones, 3 twos, 3 threes, 3 fours, 3 fives, like that. Now B is having X such that X is again a natural number, but less than 6. So I will write 1, 2, 3, 4, 5. Now when I write A intersection B, I will take common. 3 is the only number common in both. Let's go to fourth question. A is a set having X such that X is a natural number and X is greater than 1, less than or equal to 6. That means when I write the numbers or elements, I'll write 2, 3, 4, 5, 6. B is the set having X such that X is a natural number and X is greater than 6, less than 10. So I will write 7, 8, 9. When I take A intersection B common in both, I don't find anything common in both the sets. So it is just an empty set. Okay, fifth one. A is the set having 1, 2, 3 and B is empty set. So when I take A intersection B common in both, I don't find anything common. So here I have empty set, here also empty set as the answer. Now let's go to question number 6. A is having 3, 5, 7, 9 and not 10 but 11. 3, 5, 7, 9 and 11. B is having 7, 9, 11, 13. C is having 11, 13, 15. And finally, D is having 15, 17. First, you have to find A intersection B. Common in A and B. 7 is common, 9 is common, 11. 7, 9 and 11. Okay, second. B intersection C. Common in B and C. 11 is common, 13 is common. So 11 and 13. Next, third one. A intersection C intersection D. Common in A, C and D. I don't find anything common in A, C and D in all the three. So it is empty set. Okay, fourth one. A intersection C. Common in A and C. Only 11 is common. So only 11. Fifth one. B intersection D. Common in B and D. I don't find anything common. It is empty set. That is 5. Next, sixth one. A intersection B union C. So I will write A 3, 5, 7, 9, 11 intersection B and C union. So first I will write B, elements of B, then elements of C. 11 and 13 I will not write, I will write 15. So when I take intersection, the common 7, 9, 11, these three are common. 7, 9, 11. Next, seventh one, A intersection D. Common in A and D. I don't find anything common. So it is empty set. Next, eighth, A intersection B union D. So first I will write A 3, 5, 7, 9, 11. Intersection, I will write B union D. First B's element 7, 9, 11, 13. Next D's elements 15, 17. I have to find intersection that is common. I can find 7 common, 9 common, 11 common. 7, 9, 11. Next, ninth. A intersection B, intersection B union C. First A intersection B, Common in A and B already we have written here. 7, 9, 11. Intersection B union C. Already I have written here B union C. 7, 9, 11, 13, 15. Now I have to take intersection means common. 7, 9, 11. These are common. Next, A union D intersection B union C. First A union D. I will write the elements of A, then D, 15 and 70. Intersection B union C already I have here. 7, 9, 11, 13, 15. Now intersection you have to take common. Common is 7, 9, 11, 15. 7, 9, 11, 15. So with this we have completed question number 6. We can go to question number 7. A is the set having X such that X is a natural number. That means you will have 1, 2, 3, 4, 5, all such numbers. Next, B is the set having X such that X is an even natural number. Even natural number. That means 2, 4, 6, 8, 10, like that. It goes on. Next, C is the set having X such that X is an odd natural number. So now you have to write odd natural number. 1, 3, 5, 7, 9, and so on. Next, D is the set having X such that X is a prime number. So now we will be writing prime number. So when you write prime number, 2, 3, 5, 7, not 9. After 7, next prime number is 11, so on. It goes on. So first you have to find A intersection B. Common in A and B. 2 is common, 4 is common. Like that, 2, 4, 6, 8, 10 will be common. Second one, A intersection C. Common in A and C. 1, 3, 5, and so on. 1, 3, 5, 7, 9, and so on. Third one, A intersection D. So common in A and D. What are common? 2 is common, 3 is common, 5 is common. So you will have 2, 3, 5, 7, 11, all these common. Fourth one, B intersection C. Common in B and C. I don't find anything common. So it is empty set. Fifth, B intersection D. Common in B and D. What I see common? Only 2 I see common in B and D. Sixth one, C intersection D. Common in C and D. 3 is common, 5 is common, 7 is common, like that. You will have 3, 5, 7, 11, 13, so on. All these will be common. So I can write this is nothing but set of even numbers. This is nothing but set of odd numbers. Here the answer is nothing but prime numbers. Of course, here it is empty set. Here it is even prime number. Here odd prime numbers. You can just describe them like this. That is an extra information they did not ask, but nothing wrong in writing that. Okay, next question number 8. Which are disjoint sets? You have to write which are disjoint sets. First one, 1, 2, 3, 4 and x such that x is a natural number and x is greater than or equal to 4, less than or equal to 6. That means this set is 4, 5, 6. If you take this as A and this as B and find A intersection B, you are getting 4 as the common. So this is not a disjoint set. A and B are not disjoint sets. Second one, the set A, E, I, O, U and C, D, E, F. If you name this as A and this as B, A intersection B, the common is just A. So here also A and B are not disjoint sets because you are having common elements. Okay. Third one, x such that x is an even integer. That means the set A will be something like -4, -2, 0, 2, 4, 6, and so on. It will continue. And there is another set x such that x is an odd integer. So in this you have -3, -1, 1, 3, so on. Name this as set B. If you take A intersection B, you find nothing common. So this is disjoint sets. That means here I can write A and B are disjoint sets because nothing common. Shall we go to question number 9? Good. Question number 9. A is having 3, 6, 9, 12, 15, 18, 21. Next, B is having 4, 8, 12, 16, 20. C is having 2, 4, 6, 8, 10, 12, 14, 16. And D is having 5, 10, 15, 20. You have to find a few sets. Like the first one, from A, remove B. So 3, 6, 9, 12 you have to remove. 4 you can't remove, 8 you can't remove, but 12 you can remove. 15, 18, 21. This is what you have. Second one, A minus C. So from A you remove C. Like you'll write 2 you can't remove, 4 you can't remove, but 6 you can remove. Then 8 you can't remove, 9. You have 9. Then 10 you can't remove, 12 you can remove. Then next 15. Okay. 14 you can't remove, 16 you can't remove. So you will have 18 and 21. So that means for A minus C, you have having 3, 9, 15, 18 and 21. Third one, A minus D. From A, you have to remove 5, 10, 15, 20. 5, 10 you can't remove. 20 also you can't remove, but 15 you can remove. So 3, 6, 9, 12, 18, 21. These are left. Fourth, B minus A. From B, remove A. Remove 3, 6, 9, 12, 15, 18, 21. So you can't remove 3, 6, 9, but you can remove 12. So you will be having 4, 8, 16, 20. Fifth one. Question number 5 in this is C minus A. From C, you have to remove A. That is 3, 6, 9, 12, 15, 18, 21. 3 you can't remove, but you can remove 6. 9 you can't remove, you can remove 12. So 6 and 12 you can remove. Left is 2, 4, 8, 10, 14, 16. Next, sixth. Sixth is D minus A. From D, you have to remove A. 3, 6, 9, 12, 15, 18, 21. 3, 6, 9, 12 you can't remove. But 15 you can remove. Only 15. So left is 5, 10, 20. Next, seventh. B minus C. From B you have to remove C. 2, 4, 6, 8, 10, 12, 14, 16. You can't remove 2, but you can remove 4. You can't remove 6, you can remove 8. You can't remove 10, you can remove 12. You can't remove 14, you can remove 16. So you can remove 4, 8, 12, 16. Left is only 20. Next, eighth, B minus D. From B, you have to remove D. That is 5, 10, 15, 20. You can't remove 5, 10, 15, but you can remove 20. So 4, 8, 12, 16. Okay, next ninth. C minus B. From C, you have to remove B. Like you have to remove 4, 8, 12, 16, 20. So when you remove 4, 8, 12, 16, 20 you can't remove. You will have 2, 6, 10, 14 because we are removing 4, 8, 12, 16. So left is 2, 6, 10, 14 for C minus B. Next, 10th one is D minus B. For D minus B, from D you have to remove B. 4, 8, 12, 16, 20. We can't remove 4, 8, 12, 16, but we can remove only 20. So 5, 10, 15 will be the answer. Next, 11th, C minus D. From C you have to remove D. That means you have to remove 5, 10, 15, 20. 5 you can't remove, but 10 you can remove. 15 and 20 you can't remove. So left is 2, 4, 6, 8, 12, 14, 16. Then 12th one, D minus C. From D you have to remove C. That is 2, 4, 6, 8, 10, 12, 14, 16. You can't remove 2, 4, 6, 8. But you can remove 10. You can't remove 12, 14, 16. So remove only 10. 5, 15, 20. These are left off. Now we can go to question number 10. X is the set having A, B, C, D. Y is the set having F, B, D, G. Now you have to find first X minus Y. From X remove Y, that is F, B, D, G. You can't remove F and G, but you can remove B and D. Left is just AC. Okay, next, Y minus X. From Y, you have to remove X, A, B, C, D. You can't remove A and C, but you can remove B and D. F and G will be left off. Third, X intersection Y. The common in X and Y are B and D. So I will write B and D. Let's go to question number 11. In this, R is set of real numbers. We all know. And then Q is set of rational numbers. This also we know. Now you have to find what is R minus Q. So from real numbers, if you remove rational numbers, left is irrational numbers. So R minus Q is nothing but set of irrational numbers. Okay, next is question number 12. You have to write true or false. First one, 2, 3, 4, 5 and 3, 6 are disjoint sets. If you name this as A and this as B, if you find A intersection B, there is common number 3. That means they are not disjoint sets. It is false. Second one, A is the set having A, E, I, O, U. And B is having A, B, C, D. They are saying these two are disjoint sets. If you take A intersection B, you are having A common in both. That means They are not disjoint sets. This is also false. Third one. A is the set having 2, 6, 10, 14. And B is the set having 3, 7, 11, 15. They are saying these are disjoint. Let us see whether they are really disjoint sets or not by finding A intersection B. The common, nothing is common in between them. So yes, this is true. They are disjoint sets. Okay, fourth one, A is having 2, 6, 10. And B is having 3, 7, 11. They are saying these two are disjoint sets. So take A intersection B, nothing is common. It's empty set. So yes, they are disjoint sets. This last one is true. So with this, we have completed exercise 1.4. Now we can go to the theory part of next exercise. First, we will learn few concepts. Then we will go to next. Maybe this class we may not be able to go. The first concept you will be learning is here complement of a set. What is complement of set? Let us take, for example, U, universal set. It consists of all prime numbers that are not divisors of 42. So 2 is the divisor you can't take. 3 is the divisor you can't take. Prime numbers I'm taking. What all we will get, we will see. All prime numbers that are not divisors. 2 is the divisor you can't take. 3 is a divisor you can't take. 4 is not a prime number. Then 5. 5 is not the divisor. So 5 you can take. 7 you can't take. 7 is the divisor. Right? 8, of course, not a prime number. 9, no. 10, no. 11. 11 is not a divisor of 42. So I can take 11. 13 is a prime number but not divisor of 42. So I can take 13. 17 is prime number but not a divisor. 19 is a prime number, not a divisor. Like that, if you go further, 20, no. 21, no. 23 is not divisor. Prime number but not divisor. 24, no. 25, no. 26, no. 27, no. 28, no. 29 is not divisor but a prime number. Then 30, no. 31 is prime but not divisor. 32, no. 33, no. 34, no. 35, no. 36, no. 37 is a prime number and not divisor. 38, no. 39, no. 40, no. 41 is prime number, not a divisor. And then 42, of course, you can't take. Until here, these all are prime numbers and they are not divisors of 42. Suppose instead of U, I will take this as A. And U, I will take all prime numbers. All prime numbers means 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, and 41, so on, all prime numbers. Then, if I take from U, I will subtract A. What all are there in A? I will write 2, 3, 5 I will remove, 7 I will write, 11, 13, 17, 19, 23, 29, 31, 37, 41. These all I will remove. So I will be having just 2, 3, 7. This is only complement of A, complement of set A. So if someone asks you to define complement of set A, it is U minus A. Or you can say all the numbers x such that x belongs to A, U, but does not belong to A. X belongs to U only. It doesn't belong to A. That is the definition of complement of set. Okay. Now let us take one example. U, I will give you 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And A, I will give you as 1, 3, 5, 7, 9. So if I want to find A complement, I have to take U minus A. From U, you will remove the elements of A. 1, 3, 5, 7, 9. Left is 2, 4, 6, 8, 10. This is how we will write A complement. Okay. Another question. U is set of all students of class 11 and A is set of all girls in class 11. So what will be A prime or U minus A? From U, remove A. So left is all boys in class 11. This is how you can write. I think we don't have time to do or go to another question, another example. We will end the class. Come prepared, whatever you have learned until now for the next class, so that you will feel the next class easier. See you in the next class.